Hello, madam. I'm Randhir Chen. So, we are from group number 61. This presentation is about a sustainable substitute for a cement in concrete. The names of the group members are shown on the bottom of the slide. So, in this present world, all the industrial companies and other production companies are trying to apply green engineering and sustainability to their production. So, our task is to find a sustainable substitute for cement in concrete in this project. So, we think you can get a good understanding about our solution after watching this presentation. So, this slide shows the contents of this presentation. As you can see, we will introduce our substitute step by step during this presentation. First, we discuss what are the main ingredients in concrete. There are mainly four ingredients in concrete: cement, water, fine aggregate, and coarse aggregate. There are several cement components also in the concrete: lime, silica, magnesia, alumina, sulfate, sulfur are some of them. Those are non-renewable, and all the ingredients except water are non-renewable in concrete. So this slide shows the properties of concrete. These are very important because the quality of the concrete depends on the properties in it. So workability of concrete, segregation, compressive strength, tensile strength, etc. As you can see, those are the main properties of the concrete. Let's define them. Workability of concrete. There shouldn't be any segregation and bleeding after compacting in good workable concrete. Segregation. Uh, Segregation is separation of coarse aggregate from the concrete. A good concrete should show less segregation after mixing. Bleeding makes the uh, concrete weak. Compressive strength also very important property to concrete. Tensile strength affects the extent and width of crack in the structure. Shrinkage causes for surface cracks. Durability also very important to the concrete. Creep, it depends on the duration of sustained loading. Modular ratio simply the ratio between stress and strain. So those properties are given to the concrete by its ingredients. So I would like to hand over this presentation to Maldikara JC to continue. Thank you.
Thank you, Randhire. I'm Mallikara Chessi. As you can see in the slide, firstly, I would like to tell about how the cement is made. As the first step, all the raw materials need to be mixed. Cement, water, sand, and crushed stones are the basic raw materials for that. Their percentages are shown in the slide. Then that concrete mix need to batch, transport, compact, mold and cure. So at last we can get hardened concrete. Electricity is needed as the power source to this procedure. There are many uses and applications of concrete. Concrete is easy to maintain and it also cost effective and energy efficient. Concrete has high durability and can hold up against weather and fire conditions. Strength of concrete increases over the time and it is environment friendly one because it doesn't release any volatile organic compounds into the air. Also, concrete has multiple design possibilities and it is safe for building occupants. Because of that quality, concrete is one of the most used products in the field of civil engineering. Concrete is used for make bridges, highways, buildings, tanks, tunnels and etc. There are four life cycle stages of concrete. Extraction of raw material is the first stage. Manufacturing cement and applying concrete are the second and third stages respectively. Repairing and rebuilding is the final stage. Concrete is a good product but it also has several problems related to life cycle stages. Firstly, in the extraction of raw material stage, it occurs resource depletion because of limestone extraction. Also, releasing a lot of heat from the mining areas cause air pollution and destruction landscapes for mining is another severe problem related to this stage. High energy use, global warming and fuel emissions are happening in manufacturing cement stage. Increasing solid waste in environment and health effects by dust are the main problems that occurred in third and fourth stages. By considering alternatives for concrete, we could find out several solutions for that. They are fly ash, silica fume, metacolin and ground granulated blast furnace slag. Then we found out how can solve these problems by using each alternative. Fly ash can reduce consumption of energy, reduce cost, reduce carbon dioxide emissions and reduce destruction of landscapes because fly ash is produced by coal. Silica fume isn't associated with carbon dioxide emissions, so it also a plus point. Metacolin increases structural lifetime and it can decrease solid waste of the environment. Ground granulated blast furnace slag can increase durability of the concrete and can decrease the solid waste of environment. So thank you and I will hand over this presentation to Vijay Ratna PSM.
Thank you, Sakila. I'm Vijay Ratna PSM. Selecting the best alternative was a complex procedure. After identifying each of the alternatives that we have along with the problems of the original product that will be solved by them, we had to discover how much will it suits to be an alternative considering the properties those will give to the final product of concrete. After all those filtrations, we found that the best solution was to use fly ash along with GGBS as an alternative for cement in concrete product. Here you can see some of the properties of fly ash and GGBS which are more similar to properties of cement. GGBS increases compressive strength, flexural strength and tensile strength up to 30%. It increases workability and enhances sodium sulfate resistance and gives better durability against silage effluent cycles and salt crystallizations. And when fly ash is used, it gives compressive strength, tensile strength, flexural strength, and it increases them. Resistance to alkali aggregate reactions are much high. It slows down ingress of moisture, oxygen, chloride, carbon dioxide, and aggressive chemicals and prevents corrosion. In the next slide, we will see the evidences that possess to show that these are the best fits to be placed as cement. The strength of concrete contains metakaolin is very high, less bleeding in concrete than other concretes. After 7 days, drying shrink rate strain of concrete is low. Metakaolin leads to obtain high durability, acid resistance, and high density. Silica fume concrete is also can be used as ordinary concrete. The compressive strength is higher than ordinary concretes. Creep is lesser than normal concrete. Possibility of bleeding and segregation is low. Density varies from 150 to 700 kilograms per cubic meters. Incorporation of fly ash and GGBS as partial replacement of cement in concrete gives good result in both fresh and hardened state considered to the above mentioned two alternatives. In low volume replacement mix M2, 20% of fly ash together with 20% of GGBS and 60% OPC gives good workability and strength. In high volume replacement mix M7, 40% fly ash with 20% GGBS and 40% OPC gives good workability and strength. Making concrete with combination of fly ash and GGBS and cement with different percentages gives good results compared to control concrete. So the best way to use these materials is in combination. Due to environmental issues in the production of cement, industrial byproducts like fly ash and GGBS are used as supplementary materials in concrete, and it saves cost of production of concrete and it makes eco-friendly. Considering all those what we observed and identified, we were able to arrive at a conclusion that fly ash and GGBS will fit to the position of cement in product concrete, since it has almost all the properties which are in regular cements, completing environmental friendliness by fulfilling sustainability as well as protecting green engineering perspectives. Here are some of the references that we rely on when gathering and studying information based on our project. Thank you all for your precious time.